Okay, ions. Atoms can form ions by gaining or losing electrons. The number of protons stays the same. That's like the soul of the atom. That can't change. But the number of electrons can change. The electrons are a little bit like your clothing. You can take your sweater off. You could put a jacket on. You could go barefoot. You can change what you're wearing, and that may make you look different. And yet, you are still the same person. The number of electrons can change. The number of protons cannot change. So here we have a picture. I'm just wondering if, okay. Metals tend to lose electrons, to form positive ions called cations. So here we have a picture of magnesium. Magnesium is element 12 on the periodic table. So it has 12 protons. The atom is neutral, so it has 12 electrons. So out here in this cloud, we have 12 electrons. Well, this tends to react in a way that it will lose 2 electrons, and we'll learn why it does that later. For now, we'll just learn that it does that. Now it's got 12 protons still, because that doesn't change, and 10 electrons, and the charge will be 2 plus, because we lost 2 of the negatives that were balancing out the positives, so the charge is 2 plus. This is called a cation. Cations have positive charge. If you like cats, I've got a good way for you to remember that. I like cats. We're currently down to 2 cats. We were up to 6 at one point briefly, but our 2 old cats died this year. But I have positive feelings for cats. Cat ions are positive, okay? If you don't like cats, you're on your own. I'll still teach you, but you're on your own for this. So how do we name these? The cations are generally just the name of the parent atom. So the magnesium ion formed from magnesium, its name is just magnesium ion. We don't do anything funny to its name. Nonmetals tend to form negative ions by gaining electrons. So nonmetals form negative ions. So that can help you remember it. The number of protons has to stay the same. So in order to have a negative charge, you gain electrons. You gain negative charges. So here's a picture of chlorine. Chlorine's element 17 has 17 protons. The neutral atom has 17 electrons. If we give it an extra electron, now it's going to have, where's that number? 18. 18 electrons. 18 electrons, 17 protons. Now we've got an extra negative charge, and so it's got a negative charge. Negative ions are called anions. So both of these names, cation and anion, end in the word ion. Anion has an extra N, and that's the negative one. It looks like anion, but it's not an anion. And cation looks like cation, like short for vacation, but it's not. And if you say anion and cation, I'll snigger at you. It's like small children mispronouncing words. It's really cute and all, but it's funny. When we name an anion, we do change the name a little bit. So this listed here. This is the neutral chlorine atom. Chlorine is the name of the element. When it's a negative ion, we change the ending. So chlorine becomes chloride. You take the element name and you change the ending to "ide." Okay?
So when it's talking about losing it, where does it go?
That's a good question. When you talk about losing an electron, where does it go? It goes to another atom. So we don't have just electrons floating around by themselves. If an atom loses an electron, the only way it can do that is if the electron goes to another atom. And the only way an atom can gain an electron is if it gets it from another atom. There's no electron bank. You can't just, go to the bank and get money. You have to get it from someone else. So I liken electrons to small babies. So like you're going to the amusement park and you've got your baby with you. You don't just set the baby down, and you don't just go find babies by the side of the road. You give them to another person to hold and take care of, right? And so if I'm going to have an extra child, it's because some other mom wants me to babysit her baby, right? And so then I have extra children.
So within a molecule, you can have a chlorine atom or a chlorine ion?
Yes. And ions are going to form different types of compounds than the neutral atoms will. These are great questions, and a lot of them will be answered better as we learn a little bit more. So ion charges are predictable from the periodic table for many of the elements, not all of them. So these groups, these columns in the periodic table, have predictable charges. And we should be familiar with their names as well. The alkali metals are the group 1A, or some charts like the one on the wall just says 1. Group 1A, all the elements in that column, they all form +1 ions. So group 1 forms +1. The metals tend to lose an electron and become positive. The nonmetals are negative. And then the group number tells us about how many they will do. The alkaline earth metals are in group 2A. They form a 2+ charge. The group 3A metals form 3+ charged ions. How's that for a nice pattern? Group 2, all of them, +2. Group 3, the metals, because boron's not a metal, the metals in there form +3. Then there's group 6A, which doesn't really have a name. They form -2 ions. Group 7 is the halogens, that's their family name. They form -1 ions. And the noble gases are in group 8, and they form ions with no charge. They don't form ions. Okay, so how do you remember those nonmetals? The metals are easy. How do you remember the nonmetals? Well, what seems to work the best for most students is to think of playing a weird board game. And so I'm going to start, you're going to start over here, you're going to start, this is the start square. And I'm trying to figure out what the charge on oxygen is. And you count how many spaces do I have to move backwards? Because backwards is negative, right? So I go -1, -2. All these guys are -2. All these guys are -1. So for bromine, I'd start here, and I go back -1. Bromine is -1. I'm not sure why they didn't put this in this periodic table. What would this guy be? Right here. -3. So that's nitrogen. And he forms a 3-. It's not a very good minus. That's an even worse minus. Let's fix that. There we go. And below phosphorus, below nitrogen is phosphorus. What charge does he have? 3-. Okay. Do you see the pattern? We're going to be using this pattern a lot. So over here, group 1, +1 ions. Group 2, +2 ions. Over here, these metals in group 3, +3. The metals form positive ions. The non-metals form negative ions. And you figure out the charge by counting backwards. So 0, -1, -2, -3. This column here in the middle doesn't really form ions. Carbon doesn't form ions, and the rest of them, silicon, germanium, they don't really form ions. When we get to the metals down below, they form ions, but they're not very predictable. So here we're going to test what we've learned. An ion with a 3+ charge contains 23 electrons. Which ion is it? Okay, so how do we do this guy? Well, here we've got 23 electrons. And it says it has a +3 charge. So what we need to know is we need to know how many protons this guy has so that we know which element he is. So if it's got a +3 charge, does that mean that we have more positive charges or more negative charges? More positive charges, right? So that means the number of protons is 3 more than the number of electrons. We could do formulas and stuff, but that doesn't really work very well here. You just kind of have to think it out. So 23 electrons, the protons, there must be 3 more, so it must be 26 protons. That tells us what the element symbol is. We look on the periodic table, 26 is iron. So this is iron, and then we indicate the charge as a superscript to the right, so 3 plus. We write the number first, and then the sign. This is opposite of how you do it in math. In math, you would write like x to the minus 3. But we would write like phosphorus with a 3 minus. I think the reason that we do that is to avoid confusion. We don't want to look at this guy and say, well, that's phosphorus raised to the minus 3 power, right? No, that's phosphorus with a 3 minus charge. But here's our answer to this question, iron 3 plus. Any questions? So this was multiple choice, and there's the answer. Okay, compounds that contain ions.